Alrighty guys, what's going on everybody? Welcome back here to another live stream, my friends. I hope everyone is having a great day out there. Glad to have you guys here for another update. Let's go ahead and hop our way over here to the main program, my friends. What's up everybody? Let's see who we got here for today. We got ourselves Roadster Jim, we have Haley, we have John, we have Cassandra, we have Aiden, we have Katie, we have Xavier, we have, let's see, 06 Tradrew. Anyways, we'll call you Drew. We have Blue Sea. Let's see here. We have Yapper. We have, let's see here. We got Braven. We have Mark. We have Mothman. What's up, guys? Hope everyone's doing good. TRG was here. I don't know if he's here or not anymore. But anyways, y'all. Hope everyone's doing well. Anyway, so, yeah, we got ourselves a new risk that was added by the Storm Prediction Center here for Texas that we are going to be looking out there for. We're going to dive into models and stuff like that too, and kind of, you know, get an idea of what things could look like. So we'll definitely, we'll jump into that here in a moment. But let me go ahead and bring this up here. We're going to go ahead and bring up the risk area here. This is for day 6, which day 6 I believe is Thursday. Oh, this program's doing the stupid thing again. Hold on. I'm just going to have to hop you guys over here to this one. Yeah, so, anyways, but whenever it comes to it here, if we hop over here to the day 6 view, we do have ourselves a 15% risk here issued by the Storm Prediction Center regarding the potential for severe weather. Now, let me go ahead and let me bring up my pen here for you guys so I can actually draw on the screen now and later and stuff like that. So, we'll go ahead and bring this up for y'all. But yeah, so they did include a risk out there. This does include areas like southeastern Oklahoma, portions all the way down through portions like, you know, northeastern Texas, central portions of Texas. We got ourselves another risk regarding the possibility for severe weather. So, like I said, this will be taking place on Thursday. There's about almost 10 million people at risk here. As of right now. Now, please note that this is going to change over the next couple of days. You know, the risk area is going to be moving around a bit. That's typically how it works is, you know, whenever they issue the first risk of severe weather for a given event, you know, this far out, it's going to wiggle around. You know, as new model data comes in, we get more information on the storm, you know, the risk areas is going to change. So keep that in mind. You know, it could get bigger, it could move up, it could move down, it could move to the right, it could move to the left. You know, like I said, there's a lot of things that can still happen to this event. You know, it can still change a bit. But for right now, we got ourselves at 15% risk across the areas here in the northeastern side of Texas. Now, this does include Dallas. This does include the Fort Worth area as well. This also does include like Arlington. Is it Plano? I think it is Plano and Garland. These are some pretty populated areas here. You know, large populated centers here in risk area. So yeah, so Dallas, Fort Worth area, Arlington, Plano, and Garland. These areas here is in the risk here as of right now. Come Thursday. So definitely we will keep it out there for that. Now, real quickly, let me bring you guys over here. We do have the remainder of this little event popping off here across like Florida right now. Just got that little line rolling through. Overall, it's, a couple severe storms, still theoretically possible. We do have a marginal. I think they just updated the SPC's risk here for today. Let me go ahead and open this day 2. Hold on. Day 1 outlook. Yeah, there you go. So there's just a little itty-bitty marginal. Yeah, the odds of severe weather is actually really low. Currently, there is no severe storms. We do have let's see here. What is this? A special marine warning in effect. But that's out there towards Delaware. That's interesting. And towards Delaware Bay. Let's go ahead and bring that up real quickly. Go ahead and pull some data here real quickly. But yeah, no, I wanted to mention that. The line is pretty weak. There's nothing severe on it though right now, so that is, that's definitely good news here. Let's see here. What's up, Christy? Hope you're doing good. Let's see here. What's up, Haley? What's up, Florida man? Let's see here. Wind starting in Crystal Rivers. I'm so tired. Chased yesterday in eastern Louisiana, southern Mississippi, then drove all the whole way back. Wow, that's crazy, man. What's up, Kathy? What's up, Haley? What's up, Roadster Jim? What's up, Cassandra? We're doing good. It's a 39-mile-an-hour wind. Oh, there it is. Yeah, right there for, was that the Delaware Bay? Let's see here. We got that warning there for winds 34 knots or greater. Gotcha. Yeah, anyways. But yeah, but let me go and bring you all back over here. But yeah, so, that line's rolling through. Currently, right now, we also have ourselves another little storm system rolling across the Pacific Northwest here, starting to bring in a bit of precipitation. I'm going to turn off the satellite view. There's actually a bit of snow for those upper elevations that's we're experiencing out here towards Washington State and stuff like that. Southwest pretty clear. Got a few showers out there by like eastern Arizona, portions of southwestern New Mexico, but these are starting to fizzle out. It looks like they're gone actually. That's good. That's good. Yeah, but it's really just this little line that's going to be rolling through like north central Florida here. The system's pretty much dead for the most part. I was not able to be live earlier, unfortunately, because a lot of important things came up here. But yeah, so we'll definitely, like I said, we'll definitely watch this next system over the next couple of days coming through. But yeah, let me go and bring you all over here to models. We're going to take a look at that here. Let's go and see what we got going on in terms of models. Let me go and bring up the GFS here. Yeah, we're going to look at the GFS. We'll also pull up the Euro at some point. That way we can compare the two models per se. So like I said, this is for Thursday. This is gonna be popping off for Thursday. Right now we're taking a look here at the instability, the potential energy in the atmosphere, and you can see that as we work our way over here towards Thursday, here for 21 Zulu. So this is like late Thursday. There is a good amount of instability available across Texas. Now, here's the thing. This model actually shows it going up well even further up into like the Midwest. So based off of the GFS model, this is showing that there might be a possibility that severe risk, could maybe go a little further up north, considering that there's also higher wind shear up in that region too. So we will need to watch that. Let me actually just bring out a bigger view overall. Let's go ahead and see. We'll go and bring back up our cape here. Wow. Okay. That's interesting. Yeah, so Thursday, according to GFS here, cape with a non-capped environment. Well, some of it's capped, obviously, but, there is some places, throughout this area, like, Missouri and even, like, Western Illinois. Now, obviously, this is going to change, more than likely, considering, still a couple days away. But we got ourselves, like, Texas, Louisiana, and all those areas going on there. So, I mean, honestly, there is a lot of instability available according to GFS here. Let me grab a couple soundings. I'm going to grab one across, like, east central Texas here. We'll go ahead and grab one here. We'll take a look at that, and then we'll go up the chain here and kind of see. So here's a sounding from east central Texas here. There is a little bit of, like I said, there obviously is a little bit of that. I should probably use a different color. There's a little bit of veering here in our lower atmosphere, so there is a little bit of veering. Wind shear is fairly weak, though, in our lower levels, according to this model here, so I doubt it would be anything significant. Yeah, helicity is very low. This would likely not produce anything like that big. I mean, if anything, a weak spin up, tornado brief spin up. There's a pretty good amount of instability throughout our mid-atmosphere, though, which is interesting, but, there is a bit of... there definitely is a bit of instability out in that region. D-Cape here. So downwards energy, essentially. We're seeing the possibility, maybe some damaging winds could be a possibility, given the fact of that. But, it wouldn't be anything significant, just considering our lower level winds as well are pretty weak. So that downwards energy won't be bringing too much, too strong wind gusts, at least from that sounding. I mean, obviously, once again, that's just, that's just a little... just to look at things here, and like I said, it's going to likely change here. So I just grabbed one across. Was it Central Missouri here? Another sounding. So it looks like, once again, first of all, we have a lot of instability available in our atmosphere here. There is wind shear is mostly non-directional. So our wind shear is relatively moving in the same direction here. I don't see this being like a super prone tornado environment, but maybe just severe thunderstorm, capable of probably some hail and maybe some regarding the possibility of maybe some damaging winds and stuff like that could be a possibility, but right now, like I said, I mean that's not really too crazy. Let's grab one towards central Illinois here this is Zulu for Friday, so this is actually for still late Thursday, but universal Friday. We got a bit of inversion in our lower atmosphere that would probably Yeah, that would probably prevent these storms from happening, unless we had like a really strong source of lift that could help puncture that that little cap there in the lower atmosphere. Um, yeah, once again, mid-level atmosphere, there's a lot of instability, a lot of fuel for these storms to really kick off here. And our wind shear, once again, is relatively non-directional. We do have a slight change in wind directions. You can kind of see how it goes from, let's see here, how it kind of goes from like northeast to mostly east. So there is a little bit of a wind directional change there, but once again, nothing really significant. Yeah, our helicity, which measures like potential cyclonic updrafts, is pretty weak. So, with that being said, I mean, I don't see anything spectacular for those areas. But let me go ahead and do something real quickly. We're gonna go ahead and highlight. We're gonna go ahead and circle this area here of where some of that convective available potential energy is at. We'll go ahead and bring up our lower level winds here overall. So we can see our strongest winds at the lower levels is across these areas here. We've got a little bit of a jet popping off over here as well. And our mid-level winds here are the strongest up here. Yeah, our mid-level winds are the strongest up here. So if you really mix all those together, we'll go ahead and grab a. So we'll go ahead and grab like another sounding. Let's try like out there. I don't want to grab one on St. Louis because it's a capped environment according to this model. But let me go ahead and grab one for northeastern side of Missouri here. We'll go ahead and take a look at that and see what's going on here. So this one, okay, so this model as well, or this sounding I should say as well, you can't see it because here, I'll go ahead and hide my camera for a minute. There's something called decape, which is downwards potential energy essentially. Decape stands for downwards convective available potential energy. Some people call it downdraft convective available potential energy. So it's basically negative buoyancy, which is that cool air that's coming back down in your downdrafts, which could support some damaging winds. Depending on how much cape you have. If you have a lot of decape, it could really enhance the possibility of some strong downwards movement in your thunderstorms, which could support the possibility for like damaging winds and stuff like that. But given the fact that like our wind shear, our lower level winds, I mean they're not anything super crazy. I mean we're talking like lower level winds, right around 30 knots or so, like 30 knots. Which I mean that it's doable, but it's nothing significant per se. So that's that. But yeah, we'll definitely keep an eye on it. Let me go ahead and bring up here. I'll bring all back over here for a minute. But yeah, let me go ahead and bring up the ECMWF here. I'm curious to see what the Euro. I'm curious to see what the European model has to show. Did you guys see that new AI enhanced model? It's here. Let me show y'all. It's the European model, the ECMWF. But it's called the ECMWF AIFS, which is an AI, artificial intelligence enhanced model, which is really interesting. That's relatively new to the meteorological world here. But we're going to use this model. Let's see here. Actually, no, we're not, because it's not as good as the normal ECMWF in terms of like widespread things we can look out there for. So I guess I'll put my camera back on here, y'all. Yeah. So, anyways, all right, yeah, we're going to have to hop back down to 12 Zulu because that's the long run here. Yeah, because so the ECMWF has like 2 different run modes. So I think it's every 0 Zulu and every 12 Zulu of each day, there's a run that goes out to 234 hours. And every 18 Zulu and 06 Zulu, it only goes out to like 90 hours. Yeah, goes out to like 90 hours there. So it you can see like it has one long run and then it has a short run. Then it has a long run, then a short run, then a long run. So 2 long runs and 2 short runs per day. Now, since we're forecasting for Thursday, given the fact here, we're gonna have to look at the longer run, which is the last one was 12 Zulu, which was pretty not old, but it was well earlier today. Anyways, but yeah, so let's go and see what the Euro has to show us here. We're looking at the instability here. As we approach Thursday. Yeah. So Thursday, there is a pretty good amount of instability available, according to the ECMWF here, in kind of the same areas here. Maybe a little bit lower according to like the GFS. The GFS had that instability a little bit more south of central Illinois. But it still keeps it up into areas like Missouri, Arkansas, eastern Oklahoma, portions of eastern Kansas, a lot of Texas, obviously. Let's see here. Let me look at the convective inhibition for 126 here. Yeah, so there is some areas that we do have a really strong cap, but there is some breaking points, throughout like eastern Oklahoma and portions out there towards like Texas and all that stuff. So this is an area relatively where we don't have that much of a cap, which that could allow for convection to freely continue. But in this case, we're going to grab a sounding across eastern Oklahoma. Let's just see what this one has to show us here. So, okay, wow. That photograph's a little interesting, but it is it's not a terrible sounding, honestly. So it's not really anything really tornadic here in the sounding, but it is definitely a really high top thunderstorm. Yeah, our equilibrium level, which is basically telling us the top of the storm here is right at 12 kilometers. Right at 12 kilometers. That's a pretty tall storm. That's a pretty tall storm, and there is a pretty good amount of instability. So there's something we call isotherms, which is an area of constant temperature throughout the atmosphere. So an isotherm of 0 degrees Celsius or a freezing point is right here. So anything above, if the red line's above or on this side of the line, it's above freezing. If the red line in this case is on the back side, it's below freezing. So all this is below freezing, all this is above freezing. But isotherms are very important. So we look at the -10 to -30 line. So we'll bring it up right here to right here. This would roughly be our hail growth zone. We do have a pretty good amount of instability. If we take our parcel path and we take our ambient temperature for that level of the atmosphere, we have a pretty good amount of instability. A bit of dry mid-level pretty dry mid-level atmosphere too. So in this case, I really do think that we could have maybe a bit of hail in this from this sounding here, from sounding and of course, decape here where we're talking nearly 1,000 joules per kilogram. So we could have some gusty winds, we could have some hail in this sounding, but, anything tornadic, our wind shear is definitely in an interesting flow. We do have a bit of veering wind shear, but it does turn back. Also, we have really low relative helicity. So the potential of, cyclonic updrafts is, regarding tornadic development, it's pretty low in that environment. So that's just more of a hail and a damaging wind threat. So that was for what, eastern Oklahoma. So that leads me to believe that I really do think there's a possibility that risk could be extended, maybe in the eastern Oklahoma if this trend continues. I believe the GFS. Let me go and bring up the GFS again here. What hour was that? Was it 126? Which was what 18? Oh, hold on. 126, which was 18 Zulu Thursday, right? Okay, 18 Zulu Thursday. Let me go ahead and grab the GFS. So I want to compare that there. 18 Zulu Thursday. 18 Zulu Thursday. There we go, 126. Okay, perfect. Let's see here. Do they not have a mixed layer cape on this site here? Huh. I guess they don't. Yeah, this model doesn't show as much instability, but let me go ahead and grab a sounding out there just to kind of see. Okay, this one's a little different. Yeah, so just off of that, you guys can see there is a bit of a difference. So we do have a temperature inversion, which also known as a cap or a warm layer. So this is going to help prevent storms from really kind of firing, because it's basically because hotter air is less dense than colder air. Colder air is more dense than warm air. So naturally, cold air wants to sink, and warm air wants to rise. So as we have a warm column of air, so as we do have ourselves, all of that, that updraft is bringing up a bunch of warm air from the surface and shooting it up into the atmosphere here. Now, as we have this warmer air, it needs that cooler air to propel itself and continue to be positively buoyant, allowing for that parcel or that updraft to continue rising and continue, starting the thunderstorm or fueling the thunderstorm. But there's a level here that we do have a bit of it. We call an inversion, which is basically, in simple terms, what it's doing is it's slowing down that updraft. Is because it's running into a warmer environment. So the parcel temperature is equal, if not lower than the air around the parcel, if that makes sense, or that updraft per se, and we'll call it in this case. Hopefully that makes sense. It's a little hard to wrap your head around it, but it is, in simple terms, I'm going to keep it as simple as possible. What this thing is doing is stopping our thunderstorms from continuing to develop. That's what it's doing. So that, in that case, is a little bit, like I said, that in itself would definitely probably prohibit a bit of storms in that environment. So once again, that's just something we'll have to see the models and how they continue to trend. Let me grab a sounding across like central portions of Missouri here. We also do have a warm layer as well, or that we do have a bit of a cap here, right around like 2 kilometers, in which it very well could slow down that updraft, so that vertical velocity, so that that warm air, all that warm moisture-filled air that starts rising, we get that updraft, and then it'll actually slow down. But it's hard to tell because it might just slow down, and then once it breaks through that warm layer, it might just continue to rise again. So the parcel would rise up to this point, and it'll stop right at your tropopause. So that's how tall your thunderstorm would be in this case. If it can break that warm layer that's located right in here. So, I mean, like I said, there is still a bit of things that we need to work out. Once we approach closer to this event overall, there is still a lot of things that we do need to work out there between the models and all that stuff. But yeah, so we'll definitely just keep an eye on it. Definitely we'll keep an eye on it for the next little bit. Let me go ahead and bring up a. Let's see here. Yeah, there's a lot of CAPE according to these models here, or a lot of potential energy per se. That could be in place across like Texas. Let me just grab call it cherry pick sounding. It might even be capped out, which it looks like it is. Yeah, there is a warm layer. Once again, you can see that little spike in temperatures there. So I'm gonna ultimately make a series on this for you guys. I don't know if it might be I might do like a YouTube series on how to read these soundings and stuff like that. So I plan on working on that soon, having it out before like storm season really kicks off. That way you guys can kind of, hear some of the common terminology we're going to be using, when forecasting these future events and stuff like that. It's something that you guys are going to hear a lot, like CAPE and, convective inhibition or send or, shear, some basic terminology here. You guys are going to hear me talk a lot. So I want to make a video for you guys that way you guys can, understand more of what I'm talking about. And I'll go like really in depth, and I'll, just knock everything else out and just focus on one terminology at a time. Like wind shear, as simple as it is, it's just winds that change direction and change in wind speed with elevation. That's what wind shear is. I mean, it's stuff like that. I'll make a whole video dedicated to wind shear and one dedicated to CAPE and convective inhibition, and I'll probably put those two together, and we'll talk more about thunderstorm development and all that stuff. So I'll make a whole series on that eventually. I do plan on it, which I think will be pretty cool. But yeah, so we'll definitely do that here probably within the next couple of weeks or so. But anyways, so according to the models though, like I said, this is the ECMWF there. It definitely does show, let me bring up the, let's see, we'll bring this back up here. It definitely does show a pretty good amount of instability available across the atmosphere here. So we'll definitely need to be on the lookout there for that. I'm going to go ahead and bring y'all back over to this one. This is for, let's see here, this is 21 Zulu, right? 21 Zulu? Yeah, so the environments, let's see. So that's 18 Zulu. So 21 Zulu, it looks like that cap breaks according to the GFS model, which let me bring you back over here. So let's go ahead and go to 21 Zulu model, and we'll go ahead and grab another sounding. So it looks like that warm layer vanishes on that one. Yeah, it does. So there's no longer a cap there. So this would, with any updraft that develops here, this is actually a really good sounding for severe storms. Not necessarily for tornadoes. It's pretty low end for tornadoes, honestly. But this sounding's good for, just severe thunderstorms in general. I mean, like, damaging wind and hail producing. Wow. That is quite an interesting sounding, actually. So, immediately the thing I noticed is that, well, first of all, we have a lot of CAPE. So between your red line here, which is your temperature, let me hide my face cam again. That way you guys can kind of see this a little bit better here. So, so think of this as a side perspective of the atmosphere, right? So here is altitude. This is your y-axis, I believe. And then your other axis here is, temperature, which is very interesting. So there we go. So this is, altitude. This is temperature. So altitude, temperature. So what's really interesting, though, is if you follow the red line. So first of all, we'll have to look at the altitude. So this is 1 kilometer up. This is 3 kilometers up, 6 kilometers up, 9 kilometers up, 12 kilometers. You can do the conversion if you want to know in feet, which, for an example, this line is right around 4,000 feet. And this line's right around 20,000 feet. So that kind of gives you a little bit of an example of kind of how high we're talking here. So, but anyways, so yeah, that's our altitude. It's also, pressure equivalent. So like 6 kilometers is right around 500 millibars. 12 kilometers is right around 200 millibars. So it's considered low pressure, and high, 1,000 towards the surface. Anyways, so that temperature, and I want you guys to know something. Like I said, there's something we call isotherms, which I'm going to go ahead and draw our freezing point isotherm. So this is basically, okay, so here's the thing. So as we go up in the altitude, and this is our temperature. So this is 0 degrees Celsius or 32 Fahrenheit, and we ride this sideways. So for an example, so obviously this is, this is our freezing point. So all of this red to the right of the, to the right of the freezing point here, this is all above freezing. All of these temperatures from the surface all the way up here to about 3.5 kilometers, all this is freezing. Our freezing point is right around 3.5 kilometers. So all of this is above freezing. So from the surface to about 3.5 kilometers. So, and of course, we continue to go up here. And so like there's negative 10 degrees Celsius, there's 10 degrees Celsius, 20 degrees, and so on. It's kind of at an angle, here, so you guys can tell us. But like I said, we call these isotherms. These are called isotherms here. Anyway, so as, like I said, warm air rises. So given this fact, so we have this dotted white line you guys can see here. So this is a very important line here, as well as our red here. So our dotted white line, we're not going to really dive into that right now, but what that, what we're seeing here is if that temperature is on the left-hand side, or if that temperature is cooler than where that parcel path is, then, so that's CAPE. All of this is energy. So we'll go ahead and circle this. So all of this here is convective energy, all the way from your surface to up here. So all of this is positive buoyancy. So with warm air that's rising, it would continue to rise until it hits your EL, which stands for your equilibrium level, which is the top of your thunderstorm, and where the temperature inverts from your troposphere to your stratosphere. I am throwing a lot of things to you guys. I'm not gonna get too much in depth anymore, but like I said, that's right around your top of your thunderstorm there, overall, and this is all of your CAPE here. So this is all of your positive buoyancy or your your convective energy. So everything would be positive buoyant. So if you think of something positively buoyant, that means it's, for an example, like a basketball in water. If you go in a pool and you put the basketball at the bottom of the pool and you let go of it, it's going to want to go up. That's positive buoyancy, right? So think of the atmosphere, because the atmosphere is basically a fluid as well. So think of it that way. So this is all positive buoyancy. But if we had ourselves the temperature, say for an example, if the temperature went to the right-hand side of this line here, did something like that, then you notice how our temperature is to the right-hand side of our parcel path here. So what that is saying is, like I said, what that is saying here is that, this is actually negatively buoyant. So for an example, think of like a bowling ball. If you put that in a pool, it's going to want to sink. So you see how I'm saying that? You kind of see that. So this air is sinking down. So at our surface, there's something we call surface CAPE, which is, positive buoyancy, at our lower atmosphere, which is, where thunderstorms start. They start off as warm air rising into a cooler environment. So as we go up in the altitude, you can see the temperature does drop. So once again, there's your freezing point, negative 10 degree marker, -20, and so on. So yeah, so as we have warm air, so say like we're going to simulate a thunderstorm here. So as warm air starts to rise, it'll hit this negatively buoyant part here, and that warm air won't be able to continue rising because the negative buoyancy is forcing against it, directly against that rising air parcel. So that in itself would that in itself is essentially canceling the forces out from one another. Now in this environment, like the actual environment of the sounding here, so what's going to happen is that this storm here, or this parcel, is going to rise. And it's going to continue to rise because it's all positive buoyancy. So everything's just going to continue allowed to rise because, once again, our temperature is to the left-hand side of the dotted white line here. So all of this is positive buoyancy, which is energy, and of course negative energy. Yeah, so I'm not gonna continue on with that. I'm just gonna leave it there, y'all. Like I said, I will definitely go back to. I'll explain it a lot better here. I'll explain it a lot better here in future videos. I'll make sure that it's actually good enough to understand, because I know I'm just kind of throwing a bunch of words at you guys here, but it's pretty cool. It's pretty cool, and it really gives you an understanding of, like I said, it's really really cool, as it really allows you to understand the dynamics in the atmosphere here. And like I said, in a current state, a sounding is, obviously from a weather balloon. The weather balloons they launch, they gather temperature with altitude, and they gather a bunch of other things, obviously, like wind speed, wind direction, once again, temperature, dew point, theta E, wet bulb, dry bulb, which is your temperature, and so on. And they can calculate so much with those data. Now, of course, models, they forecast that data. They project what the weather balloons, the data they collect, could look like down in time, right? So that'll really just kind of gives us a good view of what it could look like in our atmosphere. So for an example, we'll grab another sounding. So this is the model projecting what the atmosphere could look like. And there's a warm layer right there, like I was saying. So in this case, our warm air that tries, for a thunderstorm that develops here, warm air starts to rise into the cooler environment, then it would slow down and probably, actually it would stop right there. And therefore, our storm would not be able to reach the upper elevations of the atmosphere. Therefore, the storm would just completely die out, and there would be no severe weather, more than likely, with this, considering that we do have a bit of a cap. Now, sometimes if you have really strong vertical velocity, sometimes it can actually pierce through your cap. If it's strong, obviously if you have a weaker cap and you have stronger vertical velocity, so more cape in your lower atmosphere, that sometimes can burst right through it. And obviously you can see the mid-level atmosphere is very unstable as well, considering that all of this is your cape, all of this is your energy. So the warm air would continue to rise all throughout this atmosphere and stop right at your EL, which is your equilibrium level. So that is where your thunderstorm top would be, right around there. That's what we call the tropopause, which is basically the boundary layer between the troposphere and the stratosphere, which is two different layers of the atmosphere, in which, that's where the storm would stop, basically. But yeah, so that's just kind of what I wanted to mention real quickly, and that's what I'm really looking for with every sounding, so I can literally just, look at it and process it, within few seconds. I can kind of see what's going on in the atmosphere, which is pretty neat. So if you see me bringing up these soundings a lot, that's what it is me just looking at it and and all that stuff. But anyways, let's see here. What's up, Ninja? Hope you're doing good, my friend. Let's see here. Sorry I've been talking with the chat much. Like I said, I'm just trying to explain some things for you guys. And then another thing is our wind shear. For an example, we'll take 850 millibar winds, which, I'll dive into what a wind barb is and all that stuff, which wind barbs are super simple, super simple. So let me wait for this to load a little bit. There we go. Okay, so there's for the event. Let me go ahead and actually hop down more to the south. I probably should have done this here first. So so these are wind barbs, we call them. So you see these little guys, these are all wind barbs. I've explained them. They're pretty simple concept. So in this case, you see how they're kind of arced on this axis here. They're kind of, that's very, very bad, but they're kind of like this. It gets at an angle like that. So in this case, we have these little like knobs on the back of a wind barb. So that's where the wind is coming from. So for an example, with our wind barbs looking like this, the wind is coming from the south and pushing northeast. So our wind direction is going this way. So that's where our winds are going. Pretty simple, right? Pretty simple. Now, these little knobs that we talk about, for an example, I'll make a barb very big, like this one. So there is really 3 things you need to know with these little knobs on a wind barb. I'll draw one like this because it shows all of the different barbs here. So in this case, once again, winds are moving northeast. This is just an example barb. This is obviously not what this environment's showing. But the triangle means 50 knots, which 50 knots is about 58 miles an hour, something like that, I think. Somewhere around there. Somewhere, they're in the lower atmosphere, in the lower side of the scale, not lower atmosphere, the lower side of the scale, the correlation between winds in miles an hour and knots, it's not too far off from each other, but obviously that's not, collinear. That will eventually change. So as, we get into stronger winds, the mile an hour to knots similarity disperses. Hopefully that makes sense. But anyways, so yeah, 50 knots here in the triangle, and then the long one's 10 knots, and the half one's 5 knots. So that is that is what we're looking out there for. So it really just has that. So in this case, if we pay attention to this part of the atmosphere for this part of the time, so this is for this is really nothing significant here, you guys. But yeah, this is showing right around 09 Zulu for the 14th. So this is for the 14th. This is the day of severe weather, but this is like the morning before anything would happen. So I'm just using this as an example here. So what's going on here? So what's essentially going on here is we have ourselves like 45 knots to the northeast. So the winds are going that direction. You kind of see. So the wind barb's moving northeast there, 45 knots, because we have ourselves the barb that looks like this. So we got 4 10s and we got 1 5. So that's 45 knots. Pretty simple. And it goes off of, the compass, north, south, east, and west, right? And with our barb pointing this way, on average in this environment, about 40 knots, about 40 knots northeast. Make sense? Like I said, pretty simple stuff. Pretty simple stuff. And yeah, these winds change with altitude. For an example, we're looking at in the morning of the 14th, so I'll keep that same time period. Let me go ahead and bring up to the way up in the atmosphere. Those winds way up in the atmosphere for this time. Let's see here. Let me go ahead and bring that up here. Okay, so then you can see how beforehand, remember how the winds were moving directly northeast? Well, down here, as we go way up in the atmosphere, you can actually see the winds are moving relatively eastward. At about, that's 120 knots down there. 2 triangles, like I said, 2 triangles, which that represents 100 knots. And then we got 2 long lines, which is, like I said, 220, or sorry, 100, did I say 200? I'm sorry, 120 knots there. Did I say 220? I didn't mean to say 220. That'd be interesting if they came up with a knot, imagine they reinforced the knot, like a square for 100 knots or something. That'd be interesting. But no, the top of it goes up to the highest barb, the highest little notch on the barb is, I don't know exactly what they call that per se, but that's 50 knots though. That's 50 knots, and of course the long one's 10 knots, short one's 5 knots, so 65 knots here. Pretty simple stuff. But yeah, and if I grab a sounding, don't pay attention to anything else but this column right here, okay? And I'm also going to hide my camera here so you guys can see this real quickly. So I don't want you to pay attention to anything else. Don't pay attention to anything. Nothing. Except for this area and this area over here. Okay? So for an example, you can see these are 9 kilometers, 12 kilometers, 15 kilometers. So this is altitude. This is altitude, and it shows your winds at that altitude. For an example, 500 millibars. That's about 20,000 feet roughly. So if you follow that line, 20,000 feet up, the winds are almost 50 knots, almost 50. They're actually right at the 45 knot marker. So they're, 4 long lines, I'm running out of room here. 4 long lines and a half one. So there you go. Looks like a comb, I just noticed. Doesn't it look like combs? Or brushes? Or interesting. But yeah, so in this case, you can actually see, so this is our surface down here, and this is way up in the air. So you can see that the winds, in this case, are actually, obviously there's a cap in this environment. This is not, I'm not taking this as a sounding for severe weather, by the way. If you guys are just tuning in, this is just an example of wind shear. But in our lower atmosphere, the winds are moving north. In our mid-level atmosphere, the winds are moving northeast. And as we go up to the top of the atmosphere, they're moving a little bit more to the east. So you can see how they're changing directions as we go up in altitude. So this is what we call directional wind shear. The more that the winds change with altitude, like I said, that's directional wind shear. So if we have more directional wind shear, that means that, well, there's more of a violent shift in wind direction as you go up in altitude, and all that stuff. So. And speed shear, you'll hear another thing. Speed shear is also, so this is considered speed shear and directional shear. Directional shear meaning, like I said, the barbs here are changing directions with altitude. Speed shear means that they're increasing with speeds, so they're increasing in wind speeds as we go up in the altitude. For an example, 10 knots at the surface, about, I don't know, over 10 miles an hour. A little over 10 miles an hour. And of course, mid-level atmosphere, northeast, about 40 knots, 45 knots. And of course we go up higher. So that is, the winds are increasing as we go up into the atmosphere. So that's speed shear. The winds are changing direction here. That's called directional shear. Anyways, all right. So there's a little bit of a lesson for you guys tonight. I just want to go ahead and throw that in there with you guys. Oh, that's interesting. Speaking of barbs, look at this, y'all. So this is actually an observation. I don't know how true this thing is, but there's a barb right here, Atlantic City. So this is ground. This is a weather station on the ground. There's a 50-knot wind barb. See that little triangle there? So in this case, let me zoom out a bit here. So there's Maryland, there's Virginia. So we'll draw a little compass here for you guys. So we have north up here. Oh wow, that's a big thing. All right, so north, south, east, and west, right? So there's north, south, east, west. So the wind's actually going southwest here in this case. The winds are coming from the northeast to the southwest. So wind flow is in this direction, kind of like parallel to the coast here. And of course, you can see how we have like 50 knots. So there's a triangle here, which that is signifying 50-knot winds. Like I said, if there's a long line, that'd be 60 knots, and a half a line would be 65 knots. Anyways, but yeah, there's actually reports of 50 knots out there by Atlantic City. I don't know if that's valid or what's going on there. Let's see here, 134 knots or greater. That's what the warning is. Interesting. You know what? I could do this. Totally unnecessary, but 34 knots or greater would still look something like this. So we'll do. So that's 35 knots. So like something like that, or greater. So I don't know what I'm doing, honestly. But yeah, so that's pretty interesting. But yeah, so 34 knots or greater in that warning there, Atlantic City area. We did get that 50-knot wind barb, which is interesting. But like I said, I don't know how accurate, because there's a lot of factors that could, for one, that could be a real reading, but you also got to take into consideration that weather station cannot be calibrated, or it could be just wrong, inaccurate. There's a lot of things you got to take into consideration whenever looking at observations and stuff like that too. It's they're authentic. Their authenticity, is that a word even? I don't know. How authentic they are, and and how good and how recently calibrated. There's a lot of things you got to consider with that. But anyways, y'all. All right, we're gonna hop back over here to what we mainly are talking about. Like I said, sorry I went so off the deep end today with the live stream, and kind of like I said, sorry I kind of went off the deep end in regarding to explaining, like really going in depth today. Like I said, I'm not going to do that on stream anymore, honestly. But I will do videos. I will definitely make more videos for you guys and stuff like that on that subject. So, just stay tuned for that. I'll make some like how-to videos on how to read, wind barbs, how to what's CAPE, what's convective inhibition, what's basically just simple meteorological terms. We'll do more of that in videos, but anyways, yeah, so hopping over here to Thursday, you guys, like I said, this is the day of severe weather. This is the day we need to look out there for, once again, portions out there by, like, eastern, kind of northeastern Texas here, southeastern Oklahoma. We got ourselves a 15% risk out there for severe weather. Once again, this does include Dallas, this does include Fort Worth, Arlington, Plano, and Garland. This is, once again, the threat here for Thursday, this upcoming Thursday. Like I said, models, they do show a good amount of fuel. They do show a good amount of fuel for severe weather, in terms of CAPE, or convective available potential energy in the atmosphere. There is enough of it, and like I said, from what the models are showing, I have a feeling that the risk could extend northeast. Considering, for one, our wind shear, so those winds that change, so wind shear, like I said, basically, wind shear, the definition is it's like how much how I can't even talk, y'all. The winds changing in speed and direction as you go up in altitude. That's what I was trying to say. So changing in speed and direction as you go up in altitude. So the wind shear is higher up in these areas towards the Midwest, and not to mention there is still a lot of CAPE. A lot of potential energy that could fire off into some like areas like Missouri, with little to no cap overall. So that is my latest concern. I mean, we'll see how that plays out. I still need some, obviously, model support and stuff like that. We'll still need to watch the models for the next while. But yeah, so definitely we will keep an eye out there for that overall. We'll watch out for it, stuff like that. So let's see here. Anyways, see you do that, Andrew. Great work. Sounds good, John. Thanks, man. But yeah, so like I said, Thursday, guys, we gotta watch out there for Thursday. Just gotta keep our eyes up here. I don't think they added any flooding threats as of now, did they? Oh, I didn't even go out that far. Yeah, day 5's the furthest for flooding. Gotcha. Okay. Anyways, yeah, so we'll just keep it on it. There's the hurricanes. That's crazy, man. There was a tornado watch in southern Georgia. Yeah, John, I saw that. Like I said, I was unable to be here earlier today. Unfortunately, something kind of popped up here, so wasn't able to be live for y'all today, unfortunately. But yesterday, I did do some. I was actually there for a while, so it's good that we were there. There yesterday. So at least we covered a bit of the event. Now, actually, I want to hop y'all over here. We do have a bit of snow ongoing up here. Bit of snow actually happening. Do we have any cameras up there? I don't know. I might have cams. We might have some snow cams here. Hold on, let me look. I know New York State has some pretty good cams from what I remember. I don't know if we have any up there though. I think we do. Maybe. Don't know how good they are. Yeah, it's snowing pretty good. Up there towards like east central New York State, Vermont, New Hampshire, portions of western Massachusetts. A little bit of snow showers up in Maine right now. Let's see. So go out there by Albany. Yeah, so Albany, New York. It seems like it's just west of Albany. Okay, so we do have. Oh, here we go. This might work. Yeah, you can't see like anything in this. It's impossible to see like anything going on here. I mean, because like out there in Albany, it's like there is a lot of heavy precipitation. Let's see. See you later, John. Let's see. I'll try a little more west here. Oh. Camera's wet there. Yeah, it's hard to tell. It's hard to see if there's any cameras available. Let's try this one. I don't know if that's a good one or not. Yeah, it looks like rain to me. Yeah. Yeah, look at the road there. You can see a little puddle, how there's droplets hitting it. So yeah, that's rain. Anyways. All right. Well, but like I said, y'all, once again, heads up to you guys on Thursday. We'll keep it out there for the Thursday commute. Like I said, I think all hazards possible. I think there will be the possibility for tornadoes, large-scale damaging winds, potentially. There still is a lot of information I need to collect, still a lot of models that need to be ran, and so we'll have to, take it day by day. As like I said, I do think that the risk area will likely change over the next little bit, as that seems quite likely. So we'll keep it out there for that. You guys, we'll definitely watch out there for it. But yeah. So we'll keep you guys posted. We'll do more live streams like I said tomorrow. I actually plan on making a video tomorrow. I was thinking about making a video tonight on education. There was a topic I was wanting to make a video on tonight. I might have a video up for you guys later tonight. I don't know. We'll see. But tomorrow I was planning on making a video for for future weather conditions and stuff like that, and live stream tomorrow night. So that's the plan. That's the plan as of now. But obviously, we'll keep you guys informed there and all that stuff. And like I said, y'all, as of right now, like I said, the SPC, this is the Storm Prediction Center. They do have a risk for severe weather for day 6, which is for Thursday, this upcoming Thursday. So it's still a couple days away. But there's been a bit of confidence in the models talking about this event here, which let me go ahead and blow this view up here for you guys. So there you go. So there's GFS model. Work way down in time. So obviously right now we have this system rolling through. This is kicking its way up here to the northeast. The storm's almost done for. You can see if we work way down in time, kicks its way off the coast. But then of course here for tomorrow and the day after and stuff like that, we're going to be relatively dry across the central eastern country. It's going to be relatively dry. We have a little bit of a low pressure system with high pressure, so wind and flow. But yeah, so we do have high pressure, which is, mostly though it's going to be relatively calm, relatively precipitationless, and of course it looks like another little system that we're watching here for the 14th, 15th. This is that severe weather event we're watching out there for. And really anything past that is in la la land, as I always say. So anything further past that, it's in la la land, and there ain't really too much confidence on anything after that. But yeah, anything for Oklahoma next week? So like I said, we'll keep an eye on Oklahoma. For this event here, there's a possibility that, like I was saying, I think personally that the severe threat theoretically could move a little more to the northeast, maybe out there towards eastern Oklahoma, portions of Missouri. I have a feeling, just considering the way the model's been trending, more instability, stronger wind shear overall there, and so I think that would be a little bit better of an environment. It all comes down to cap and stuff like that. If there's a bit of if there's a big warm layer that could prevent these storms from happening, that would obviously be a very limiting factor. But yeah, we'll definitely need to keep an eye on it. Courtney, this is the same area. This includes Dallas, so you're gonna fly right into this place here. Yeah, so this is including Dallas, and it's for the 14th here. So be careful, Court. Yeah, that's unfortunate. Yeah, so you might have to go storm chasing, Courtney. Thanks for the info. No problem. You're welcome, Brooklyn. Anyways, let's see here. Now we're gonna hop back over here to this page here, y'all. All right, let me go ahead and hide this here. Boop. Go ahead and get rid of that there for now. But yeah. So, like I said, models, I mean, they do show a lot of energy in the atmosphere for the possibility of some, thunderstorm and some severe thunderstorm development here. And some of that some of that potential energy for thunderstorms reaching all the way up here into Missouri and portions out there in western Illinois. So, it It'll roll through that region, and like I said, that area as well. If we take a look at the lower level winds, has a higher wind shear in our lower atmosphere. So that could help organization of any storm that could happen. Could add to some severe hazards. So, yeah, your super cell composite basically just grabs a basically a mixture between instability and wind shear. It makes a composite value. But yeah, that's what it looks like. So we'll have to watch out for it. I mean, like I said, I have a feeling. So let me pull up our dew points here. Here we go. I have a feeling that the risk area will expand northeast. Once again, that's my opinion. That's what I believe overall. So we'll have to just have to see how that rolls through and stuff like that. The dew points. I mean, our lower level moisture does support it. There are dew points here in the 60s that reach up to some of those areas too. So there's enough moisture in our lower atmosphere as well. So enough moisture, enough instability, stronger wind shear, just an environment for storms and severe weather in general. So watch out there for it. Do I know what time? Not really. The timing is very much a subject to change right now, but it looks like the environment, now remember this could change, the environment could become conducive to start supporting severe weather right around sometime afternoon. Probably early afternoon through the evening is what it looks like. But remember, that could change a bit. 21 Zulu Thursday shows a pretty uncapped environment, so there could very well be some storms firing off in that area at the time. So that is that. Let's see. Yeah. No, there's definitely enough instability in the atmosphere, especially once you get up to the mid levels of the atmosphere. There's a lot of instability out there, which I think could generate maybe some hail too. Some hail and like I said, some hail, some damaging winds. Definitely, I think could be a problem. Maybe a couple tornadoes can't be ruled out either. Like I said, I do think that this is a multi-hazard threat. I do think that it is going to be an all hazards threat. Now, obviously, like I said, outbreak and stuff like that. Like I said, if you hear anybody say outbreak, kind of full of it right now. I hate to tell you this, but there's a lot of people that will already say that there's an outbreak possibly going to occur. If you hear anybody say an outbreak possible, don't trust them quite yet, because there's still a lot of things we don't know about this event, and there's still a lot of things that we need to keep an eye out there for. Like I said, we always keep it to where whatever I say on my titles, on my thumbnails, is real. Not Israel. Is real. Not Israel. This country is real. Oh my God, I'm an idiot. Anyways, but yeah, no, we'll like I said, whatever I say is realistic. I'm in it to help you guys out as much as possible. What area am I looking at? So this threat, as of right now, SPC, the Storm Prediction Center, we have the risk right now for Texas, which, like I said, given the fact with the latest model trends like GFS, ECMWF, there's a good possibility that this could move a little more northeast here. I think it could go a little bit more to the northeast out there. Kind of thinking, like I said, I kind of think it is going to be going out there towards more areas like Missouri, potentially, Oklahoma, stuff like that. Don't get political. I just said a country name. How is that political? I said Israel, not Israel. Even though they sound very similar. How is saying a country name political? I don't know. Let's see here. I don't want to get hit by a tornado. Like I said, don't don't be worried about it. See here, Dev. Yeah, Dev, don't be worried about it. There still is a lot of things that can change here. There's still a lot of things we don't know about this event. And, yeah, there's nothing to be afraid about. And, like I said, storm anxiety is a real thing. And that's actually the video I was wanting to make for you guys. I was wanting to make a video for y'all on how to help with storm anxiety. That is a video I'm going to pump out soon. I'm wanting to within the week. That way I can, obviously for people who are afraid of storms, know what to do. And I will make a checklist of things you need to do, like how to, what you need in your safe spot, and, how to cope with it. Also, in that video as well, I'll also mention the fact that you need to learn radar. I say that quite often to people who have storm anxiety. Radar is a very, very important tool. Very important tool. In which, radar is very, very important, like I said. So I'll make a video on that explaining some things like that, but I'll definitely work on that here soon with you guys, because obviously, like I said, storm anxiety is a real thing, and it's I actually used to have it. I did. It's crazy to think I used to have it. Now I don't. Now I'm literally outside during storms, which I do not recommend. But it will get better. It will get better, and that video should help you out a lot. Let's see here. Storm anxiety does exist. I know it does because I've got it. It isn't fun. I hear you, man. I hear you. Yeah, absolutely, my friend. And like I said, I'll help make a video on how to combat that, and help just overall help make it better for you guys. Let's see here. But anyways, so that's what's going on there. Classic Midwestern dad. Let's see here. Yeah. I hear you, Dev. It's definitely not the best thing to deal with. I hear you. I get it, my friend. But yeah. So like I said, I'll make a video on that here soon. Whenever I can. That's why I'm moving, so I don't have to deal with the storms. I hear you, man. I hear you. That makes sense. Do I think Indiana could get tornadoes? There's no way to tell right now, Dev. I don't think so. I don't see any main, any big hazards for you right now. Yeah, there's not enough support of really anything happening towards you right now. Let's see here. I have storm anxiety as well, but I also love them too. Yeah, it's very mixed emotions. I was the same way. So when I grew up, I used to be scared of storms. Like I said, a lot of it is the fear of the unknown and not really knowing what's going on in a storm. And you think of the bad things that happen in storms and stuff like that. And but let me tell you something that should make things a lot better. So honestly, the odds of a storm being severe and you getting a severe thunderstorm that causes damage, extremely low. Extremely low. I don't know the exact math of it, but I would say it's less than 1%. Of you actually getting severe. I can tell you that. Most storms are definitely not severe. Like I said, I'm not exactly sure the exact math on it, but I know it's very low. I know it's less than 5%. Well, it's very, very low. Way less than 5%. So, like I said, the odds are very low of, if anything, really getting crazy. And on top of that, like I said, that's why I say it's very important to learn to read radar, is because, with radar, you can see actively what's going on in a storm, as radar updates about every 2 to 4 minutes usually. That's usually when we get new radar scans, about 2 to 4 minutes. So pretty frequent. And so what happens is, with radar, there's multiple things you can look at. I mean, you can look for storms, how heavy the rain is. You can also look at hail, if it's hailing like crazy. You can also look for rotation, very important one. You can look and see if a storm is rotating. And it even is good enough to show you sometimes if a tornado is on the ground, something called correlation coefficient. That's definitely a very Very important tool. So, like I said, I know a lot of you guys that have storm anxiety is afraid of tornadoes, in which, like I said, tornadoes they're scary. They can be scary for sure. But with radar, like I said, you can, there's a lot of things you can do with it. You can learn, you can see where storms are rotating, so you can see if it's around you. So you can see if a storm is rotating, like I said. You can see if there is a tornado. In most cases, you can see if there is a tornado on the ground. Which is definitely really cool. So I'll go over an app that I'd recommend. I'm not a sponsor. I'm not going to sponsor anybody. I'm not in it for the money. Like there is a lot of people. You'll see a lot of other people doing sponsorships and stuff like that, trying to get as much money as they can. That's not me. I'm not in for sponsorships. I don't care about sponsorships, honestly. But I will give an idea of a couple apps that are good, obviously, to use to read radar. Good few radar apps. I'll also list a couple free ones as well. There's a free website that I know of that you can read radar with. I'll talk about that in the video as well. But yeah, there's just, like I said, I'll mention that stuff. But overall, we'll definitely give you everything, all the information you really need. And of course, during these big time severe weather events as well, you know me, I'm going to be here. I'm going to be streaming them. I'm going to be, preparing you guys before the event happens. I'm going to be preparing you guys before the event happens. I'm going to give you all a heads up like I'm doing right now. Of course, for next Thursday, model's been pretty consistent on a severe weather event happening. And like I said, over the next several days, I'm going to keep you informed with that. And of course, like I said, the day of will be live to cover said severe weather. And so that way, not only would you know how to read radar yourself, and not only would you know what's going on in the storm yourself, but I will also be there to talk about the storms that are happening in real time. I'll be doing the coverages and stuff like that. So that way you guys can, can see through my vision of what is happening overall. So that'll definitely be, very, very good information for you guys, so that way you guys can see for yourself, plus me talking about it as well. What's the risk of fire hazard next week? I don't know, man. Let me look at the SPC. I don't think we have anything too. Oh, never mind. We do have some pretty critical. Oh yeah, Monday, Tuesday, Wednesday. Got some critical fire threats. Oh wow, look at that. Yikes. Yeah, so yeah, a lot of there you go. Yeah, so a lot of western Texas, eastern New Mexico is still going to be in the fire weather here coming up for the next couple of days. Yeah, low humidity and stronger winds combat that or allow for that to happen. So that's Monday, Tuesday, and Wednesday. Of course, Thursday we have that severe threat for severe weather. Yeah, so we'll watch it. Of course, today we have a little marginal, but that marginal's gone, basically. Yeah, it's only for winds right now. Which, let me bring you all over here. So there's a current storm right now. It's breaking up quite a bit. Let me remove low resolution. We'll bring up the high res radar here. I guess we'll use KTBW, Tampa Bay. I'm in Indiana. Gotcha. Yeah. So Indiana, like I said, right now there's just not enough information for to see if there's going to be anything severe out that way. I'm not saying there's not, but I'm not saying that there is either. So it's just, we'll keep an eye on it. There you go. There's radar. Oh, really? Yeah, this thing has it's a little glitchy. You can probably tell. So let me restart the program real quickly, and I'll bring it back up for y'all. Oh my gosh, it did it again. Man, oh man, dude, this program is like very, very glitchy. I'm gonna need to get rid of this one. And here you go. Bring it back over here now. There you go. Yeah, got some storms out there by Ocala, just west of Ocala. But the end of the severe risk is just slightly south of Ocala, which I don't think we'll have much more severe weather going on tonight, honestly. I think it's mostly done. I got to get some rest tonight, Andrew. I hope to. That would be pretty nice. But, yeah, no, this event's mostly done. I think there still was, let's see here. Yeah, we do got a marine warning still in effect for Atlantic City here. Winds greater than 34 knots or greater. Yeah. Yeah, I think most of it's done here. Of course, we have ourselves the snow and the heavy rain up here. It's very heavy rain according to radar here. Precipitation type. Does this work? Do I play Flight Simulator? I do. I have a gaming channel. You guys, it's actually if you go up on Nightbot's post there, you'll see our gaming channel. Yeah, I just played Flight Sim. Probably gonna play it again soon. Let's see. Just terrified of storms because I keep seeing things about us getting tornadoes and hear that we are going to have a bad tornado season. Yeah, no, I got you, my friend. Dev, like I said, I'll keep you posted. And I'll let you. Oh, you'll see whenever that video comes out. I plan on I plan on working on that here very soon. Maybe even tonight. I don't know. I might work on it a bit tonight, but it probably won't be up here. I call it gaming stream. What, you want me to do a gaming stream tonight? I could. I don't know. We'll see. I don't know if it's getting a little late, though. But it is Saturday night. I mean, everybody's up at Saturday night, so. Maybe. We'll see. Yeah, I mean, I might do a gaming live stream at 11, maybe? 11 Eastern. Okay. So if you guys want to see that, subscribe to our gaming channel. Let's see here. Daylight savings. Oh, wait, is that today? Hold on a minute. Oh, it's tonight. Dang it. Oh, darn. Yeah, there's our gaming channel if you guys want to subscribe to that. Like I said, yeah, I'm gonna go live. I'll go live at 11 Eastern to do some gaming live stream. I'll do some flights, I guess. We'll do some flight sim. Yep, Springport tonight. Oh man. So what would it be? 11 p.m. right now. You know what? I'm actually excited about that partially. Reason is because, well, the conversion of Zulu, Universal Time, UTC, to Eastern Time is a lot better to convert because 04 Zulu is midnight Eastern, so that's super easy because it's an even number. 05 Zulu right now, 05 Zulu is considered midnight, so but yeah, it's gonna be interesting. My sleep schedule's gonna die probably. Yeah. Probably. But anyways, y'all. But yeah, so like I said, we'll just keep it out there for it, my friends. For the next little bit here, we'll keep you guys posted on the outlook and everything like that, and we'll just keep a watch on potential for severe weather over the next couple of days and all that stuff. So we'll keep you posted. Just an hour, it's not too bad to be honest. Yeah, it's not. But the only thing that you're going to notice is different is the fact that the sun will come up earlier, or no, later, right? Sun will come up later. Wait, let me think about that. So time goes forward an hour. So that means that the sun will come up earlier, right? So the sun will come up earlier, or sorry, later. Dude, my bad. Yeah, come up later, but the sun will go down later as well. Yeah, that's how that works. Anyways, yeah, my brain couldn't wrap around that for a minute. I was like, wait a minute. Oh, buddy. Yeah, so later it is, yeah. Comes up later, goes down later. Which, not gonna lie, that's pretty nice. I like the sun coming up later. Fall back, spring ahead. Yeah, yeah. I do like the sun coming up later, and it going down later. I think that they need to just remove time change, and I think they need to. I mean, I think that's like a big debate. We need to remove time changed here. I think we just need to keep it at where it's coming towards. I think we need to keep it at 04 Zulu Eastern midnight. I think they need to keep it in the spring forward. Let's see. I'm trying to. Don't be scared, Dev. It'll be all right. Like I said, we'll get you through this. And like I said, once again, there's not even a certainty that you specifically will get any severe weather out of this. I mean, the models, they do show a bit of CAPE, which is potential energy. Yeah, there is a little bit of potential energy out there. But like I said, models are at this range is very unknown. So we'll see. We'll see how that updates. When is the rain gonna change to snow upstate? What do you mean? It's already changing the snow right now. Let's see here. Yeah. Oh, this radar. Yeah. This is not precip type. This is here. Let me turn this off real quickly. Turn this one on, and we'll turn this one off. So if I turn on precip type, there you go. Yeah. There you go. Yeah. So there is snow up there already. Is there a precip type for this? I don't think. Is there a precip type for individual radar control? No. Oh, precipitation maybe? No. Reflectivity maybe? No. Differential maybe? No. Oh well. Unless I'm not seeing anything, but I don't think there is a way to do that. Why AZ in Hawaii is so special? They have permanent daylight. They don't have permanent daylight. One area that does is the North Pole. I think the North and South Pole stays like, or no, it's different. No, not North and South at one point. It does change though, I believe. So as the Earth is tilted one way, it's either the North Pole gets all daylight. The sun just goes around the horizon. And on the southern side, I think it's like dark the whole time. And then once the Earth's tilt changes back, then the southern side gets all light, and then the northern side gets all dark. I think that's how that works. Let's see. Anyways. Alrighty, y'all. Oh, wow, we've been live for almost an hour and a half. Okay. All right, guys. So we're going to do our gaming channel. We're going to head over to our gaming channel for a live stream. I'm going to fly some planes and probably crash and die. So we'll do that. If you guys would be curious or if you guys would be interested in joining our gaming live stream, I will go ahead and post a link to our channel now. I just want to leave a little bit of a disclaimer. It's not family-friendly like this channel is. I keep this channel obviously family-friendly because, it's weather channel. I want to keep it as friendly as possible, family friendly as possible. But like I said, just a little bit of an FYI for you guys here. Let me go ahead and share this. I'm going to copy the link. Oh shoot, did I already change? All right, so let me go ahead and hop back over here. So I'm getting ready to post it if you guys want to see that. Like I said, if you guys would be interested in, there you go. All right, there's our gaming channel if you guys want to follow that or subscribe to that, and we'll be live. Yeah, I plan on going live in about 30 minutes or so, about 11 o'clock p.m. Eastern. I guess I'll do some flight sim. I'm going to try to fly Mach 10 in my Dark Star, which would be pretty interesting. But so if you guys want to see that on flight sim, we will do that. Plan on doing some pretty crazy flights there. So, all right, y'all. Well, yeah, so that's going to wrap it up for now. Once again, I appreciate you guys for being here. Thanks for all for joining. And, like I said, we'll catch you all tomorrow. I'm going to try to do a video tomorrow, too. No promises. I'm going to try to do a video tomorrow and, of course, a live stream. I can promise you a live stream will happen tomorrow night for stuff like that. So we'll definitely, keep you guys posted on this event here. So let's go ahead and go over this one more time real quickly. So I know this globe looks very weird right now. Let me turn off the FOV. But let me go ahead and bring up our convective outlook here for day 6, which, like I said, is Thursday. These areas out there towards Texas, including Dallas, Mineral Wells, Fort Worth, of course, just north of Austin, Tyler, Texas, Waco, Texas, Stephenville, Sulphur Springs, Paris, Sherman, those areas out there where, as of now, we're at risk for severe weather come Thursday. So Thursday, we'll probably be live here for severe weather and stuff like that. So, but just know that risk area probably is not going to stay the same over the next couple of days. But yeah. So just keep that in mind. We're going to see that risk move around a little bit. Personally, I think it'll extend northeast into like Missouri and stuff, but we'll see. We'll definitely see how that goes through and everything like that. But anyways, be on your gaming channel. All right, sounds good. Let's go to Gaming Den. All right, so Roadster, you going to join us later? Yeah, we're gonna head off in here in a few minutes here on this channel, and of course we'll start our other channel, our other live stream on our other channel in about 30 minutes or so. So we'll be here for y'all for that, or you guys will be able to see that. So, but anyways, folks, well, once again, I appreciate y'all. Thank you guys for joining us, yeah. Let's see here. I think they have the same daylight the whole year. They don't have daylight saving times. Oh, okay. Gotcha. Huh, that's interesting. All right, y'all. Well, let's go and wrap it up here for now. Once again, thanks for joining, guys. Like I said, there's no reason to worry. Like I said, we'll just keep it out there for it. And if anything changes, of course, we'll let you guys know. But, that's the latest update there, y'all. But anyways, guys, thanks so much for joining. We're going to head off here in about 2 minutes, so go ahead and say goodbye to your friends, family, anybody you're hanging out with in the chat. And all right, y'all, once again, thanks for joining. Y'all have a wonderful, wonderful rest of your night, and we will catch you guys on the gaming channel here in about 30 minutes. All right? Okay, guys, thanks for joining. Catch you guys tomorrow. If you're not going to be on our gaming channel, we'll catch you guys tomorrow for another update here, possibly in a video format and in a live stream. Definitely a live stream, possible video as well. So we'll see how that plays out. Just depends on what I got going on tomorrow. So, all right, guys, y'all take care. Much love to you, and we'll catch you guys in the next one. Peace out, my friends. See you then.